Can I ask you a question, Michael?
You have a test next week. How do you set up your test? Is it terms?
We have a test next week. Yes, for the online people. For the face-to-face people, the test is on Wednesday, a week from today, right? For the online people, and let me go verify that I'm not telling you really dumb things. KNSO academic calendar. Yes. My plan is for the online people. If you can come on the Wednesday with the face-to-face people, I would be eternally grateful because that makes my life easier. If you cannot, what I normally do, and I was about to send an email and I never did, I will send it, is what I normally do is come up with a horribly inconvenient time, but one that everybody can make, or at least one that doesn't. So I normally choose something like Sunday at 2 p.m. just because chances are you're not doing anything Sunday at 2 p.m. It would suck to give all your Sunday, but and so if you're in the Metro Atlanta area, you get two choices, and I would choose the next Sunday, not the previous one. And then if you're not on the Metro Atlanta area, or you cannot make it to those two, ideally, you would go to a library or something like that and get it proctored. And but sometimes those things are costly. Somebody was telling me that in the DC area, the cheapest they could get was something like $50. So in those cases, we can have a Google Hangouts and I'll proctor it. And usually I will do it during the normal proctoring times. That way I will just be watching you on the computer while you do your stuff. If you are doing that, you need a computer with a camera and a printer, so you can print that stuff.
What's the format for the test? Do we have to like pull something off of GitHub?
No, it's paper.
Okay.
Yes. In fact, we may or may not get to it today, but have a midterm review. They actually give you a previous midterm. It's not a promise, right? But it's not a promise that those are the questions or that, right? I don't care about the number of questions, or right? It's going to be 6 questions and there's going to be 2 true or false or whatever, right? It's just, well, chances are that I'll come up with something similar. But I do put both a kind of review paper and an actual previous midterm. So there is no benefit to being in a fraternity. I make my previous test public. I haven't done it. I used to make them all public to keep me honest, so I have to come up with no questions. So yes, you can see the actual format. And next class we will actually kind of do one and see. But if I'm not mistaken, recursion became a lot more interesting once you tried to do the assignment, right?
Yeah.
Do you have questions? Right?
So if you don't call actually the method, but you call one of like parameters, it's still considered recursion?
What do you mean you
Or
call
like
the
so,
parameters?
Do you have to call like the method itself, or can you, if you call like a part of that method, then it's still considered recursion?
What do you mean call a part of that method? You want to come and type an example?
Not really.
You want to dictate an example?
So if you use like in from and you like do something in there, like on the one you have right there, would that be considered recursion if like you use it in another?
Here, you're talking about this thing.
Yeah, kind of like that.
Okay.
So you don't use all the strings contained, but you just do something with like one of the parameters.
No, that's not recursion, right? Recursion means calling the exact same function.
Okay.
Oh, so you can't just put like you just can't, like in this case, you couldn't just put screen contain sc in from, and then like put a condition that would have made it true.
What do you mean? Wait, recursion means I'm calling this same function inside the function, right?
Yeah.
So if I do this, it is recursion. It is wrong, but it is recursion. Why is it wrong? Because it's going to repeat forever. You're never changing the parameters.
But what if you put a condition that would satisfy?
The recursive call, if you ever get there, you're doomed. Because you're never changing the parameters. You're never going to get out of there when you call the same function with the exact same parameters, right? If you never change them. You could even do stuff like this, right? Looks like passing the exact same parameters, but it's not. You have changed the parameters. If you never change the parameters, right, then it's not going to work, right? Unless you never hit this thing, right? And then this is actually a useless piece of code. Chances are that's not what you're doing. So, right, as a rule of thumb, you need to change the parameters. If not, you never get out of that recursive.
So if you never get, so if you say like if the statement that you put never gets to the recursion, that's still wrong.
Well, what do you mean wrong?
Like this, like let me go down.
This?
But,
Wait.
Like, oh, sorry.
No, actually, that is an interesting one. For something like read within range, right? You are putting the exact same thing. Did you change the parameters? Right? In the assignment, you have read within range, right? That has in, out, low, and high. And you probably call it with the exact same parameters. Did you change the parameters? If you didn't, then you have a problem. If you did, how did you change it? By changing the state of those parameters. When you call in.nextInt, that actually changes the state of the parameter. You advance the input. So you did change the parameter. Does that make sense?
Okay. Alright.
So it's not the form of the call, it's that you call it without changing the parameters.
Okay. Also, as long as you change parameters.
As long as you change the parameters, it's not obviously wrong, right? I mean, you need to change the parameters so that you eventually hit the base case, right? Or that's the hope. So you could be changing the parameters in the wrong direction, and then you're still going to end up with with an infinite loop. But if you change the parameters in the right direction and you eventually hit the right place, then life will be good. By the way, if you're taking discrete math or something like that, this is recursion. This is, well, yeah, they call it recursion too, right? It's induction. Proof by induction is very related to recursion. Any other things on recursion? Should we do a million more examples? Yes?
Now I feel like when I learned programming in high school, we did all these loops, and then we did some recursion that was like very difficult. We did for like one moment, you know. And now we're doing recursion first. And at first, like last week, I said, "Oh, but it's hard." It's not that hard.
Yes!
It's actually very useful. And I'm like, so wait, so why did I get taught all these loops first, and then why don't we just
Because
do
the
everything
people who
recursion?
taught you don't know how to program. Oops, sorry, did I say that out
No,
loud?
it's
No.
okay. It's okay. They thought
That
okay.
you just made me start a flame war. Hopefully, no other teachers are listening to this recorded
in the real
thing.
world, how much do you use recursion and how much do you use a loop instead?
Um,
50-50 or like
no,
90-10?
90-10 for loops.
You like the loops more?
Normally you do loops.
Okay.
On the other hand, that 10 you cannot do with loops, right? It's more, right? You do the 90 with loops because it looks more normal. But that other 10, may not even be a 10, right? There's like a 5% of things that you cannot do without recursion. And if you don't
Or at least
understand
it's really
recursion,
awkward.
no, you can't.
Or
Like
you can't do it. Period.
you can't do
I
it.
see.
Or, I mean, you'd have to build recursion.
Yeah.
Let's do a cool example to actually show recursion. Where do we see recursion on our, in real life? But we can't do that. We cannot do that yet. But what's the standard computer example of recursion? We'll do it once we see collections. No. No, those are the ones that people use because what's the real application of recursion in your computer? You do it every friggin' day. What is this?
Oh, yeah. To move files.
What is this? What if I click on it? What happens? I get folders. What happens if I click on a folder? What do I get? Another folder, and what happens when I click on that other folder? I get another folder, right? We use recursion every day for folders, right? So every application that manages folders and files, right, uses recursion for iterating over all the files in a folder or something like that, right? We do recursion like every time. It's just how often do you write an application that manages files? May not be that often, but we do it definitely for this. What is this? What is this and this? Recursion, right? What is this?
How is it recursion?
Yeah. This stuff, right? You go looking, right? This is two levels, right? These are things, right? You could go here, right? Or you could go here, right? So this community includes all of this, so it is recursion, right? It's just, they're showing you only one level. I don't know if they have more levels. I tend to not do Craigslist, as you have seen. You go to the personals, okay. This stuff, right, is recursion, right?
Because it's calling itself and changing the
It's not calling itself. The data structures is recursive, right? Recursive data structures, chances are that you would call it with the ID of this guy, and it would go look at this guy, right? And then it's the same function call that, right? You attach some sort of handler, so that when they click on camcorders, you call the same function that shows categories, except that now you pass it a different route, right?
So like hierarchical structures.
Hierarchical structures are recursion, and we use them all the friggin' day, right?
So if you like looked at the source code
No. Chances are no, because these horrible people would have horrible stuff. Shift Apple I? No. Wrong combinations. Don't save. I didn't mean it.
I think it's a call.
More tools. Developer tools. Option Apple I. Chances are that this code is horrible. Can I see? I don't even know if you can see. I mean, this, of course, will be in.
You just right-click the page and view page source.
Not quite, but yeah. View page source.
Just can't find it.
Yeah, there is no way
There's
that's right.
so much.
Yeah.
Is that just the way that interprets it, or is that actually the way that they put the code in when they?
This is exactly what they got, but they may have this script search means now you go download this other file.
This doesn't seem to be like formatted or.
Well, actually, what they normally do is they minify it, because what they are sending you is actual source code, right? So it's to their advantage to send you the least amount of source code. So they you write it with beautiful function names that say is even, and they'll replace it with I as a function name, because that's one character rather than 6. So when you look at the code, you just go like, ah! It's not, right? This code is not designed to be read. This code is designed to be interpreted by computers and not read. You can see it more as kind of assembly language rather than actual source code. But there is recursion in every hierarchy, right? There is recursion in every folder structure in your computer. So we use recursion a lot. It's just, in fact, we'll see that you normally don't even do for loops like we're going to see later. You do for loops over collections of things. You get to a database, get a bunch of things, and then you iterate over those things. And that's what you do 80% of the time. But so recursion is useful, sometimes at least. So let's go build more stuff with recursion, right? Let's build other useful stuff. Let's see. Let's do this. Boolean read yes, no. Yeah. Wrong thing. This guy. So this is gonna read yes or no from the keyboard, right? And then return true or false if the user returns true if the user entered yes, false if the user entered no. But it will tell the user you have to tell me yes or no, right? If the user entered something else. Does that make sense? What do? We are getting print stream and the scanner. So let's print something to the print stream, right? How about this? We don't know what the heck it means, but right? Yes, yes or no. Then what do we need to do? We are gonna read, right? Let's answer, input, let's call it answer, right? Equals sc dot what? Next line, just in case, right? Now, what do we do? Let's do two lowercase. If it equals yes, what do we return?
True.
If it equals no, what do we return? Oops. Otherwise, what do we return? The exact same thing, right? Did we change our parameter?
No, but that's okay.
We did.
Oh.
Yeah, that was my
This
question earlier.
changed the parameter, right? Now the scanner has a different state. When I call sc.nextLine the next time, I'm gonna get something different. Does that make sense? So the state of my parameter changed. Sc is now different, right? It's slightly harder to see because now we have the state encapsulated, but yes.
That's
If
what I
we
thought.
use any inbuilt function like dot next line or dot int next something, if we use any inbuilt function, that means it's changing the parameters.
That depends on the function. If you do sc dot
It depends on
has
the,
next,
Yeah.
has next doesn't change the parameter.
Okay.
Maybe. I don't think it does.
How do we know that means it's changing or not?
Look at the documentation. Does it change the state of the object,
Okay.
right?
Right, so it's changing SC, the scanner SC.
Yes.
And so, okay. I wouldn't have guessed that next line changes SC in any way.
I mean,
But it
what
does.
does changing mean, right? How do I know if you changed? Philosophy and computer science, isn't this cool? When I have an object, right, I have methods that I can call on it, right? How do I know if an object changed?
You gotta compare it to the original.
I could compare it to the original, and that may not, right? How can I know without, I only have this object, how do I know if it changed? Well, I can call its methods and see if it tells me any different, right? If the methods return the same thing, then it didn't change. The methods are now going to return something else, then it changed, right? So in here, when I call sc.nextLine again, what's it going to do? It's going to return something else because it's going to keep reading from the keyboard, right? Or from whatever the heck it's reading, from a file, from whatever it's reading, right? So by calling sc.nextLine, I have changed sc, right? Usually, I would consider #next to not be changing, although who knows how the heck they implement it. But I would assume that I can call sc.hasNext over and over, and nothing changes, right? So there may be corner cases where it actually changes. Does that idea make sense? That's what changing means, right? Or you can see some effect. When I call out.println, do I change stuff?
No.
Well, yes, I affected that thing, right? Something changed in that string. I printed something, right? Does that make sense?
Is it necessary to, for this whole function read yes no, does it have to have the parameters print stream out and scanner SC? Could you do it where like you declare some stuff within the
Maybe. That depends. If I give you the parameters, what does it do? Where does it print to?
like if you give me the parameters, then I'm going to use them in the homework.
Well, why?
Because else I'll get it wrong and the grade. will-
Because I'll complain about it. Why? What's the point of giving you the parameters? And this is important, right? It's probably not terribly important
that
right
we
now.
don't screw up.
What can those parameters be? How about I do this? How can I call this, right? Let me do this boolean b equals read, has to be static. Right? So if I run this, what happens? Ask me yes or no, maybe, yes or no, yes, true, right? Imagine that I want to test this. How would you test it? Yeah, sure. Run it again. Now I'll type no, false, right? Did it once with true, once with false, once with maybe. Should work, right? Maybe, right? I can do other things like string.
I mean, this is exactly what happens when I'm coding. I'm like, I
Yes,
know there's something
that's-
that's like
that's-
this, and I'll just go with it.
God, this is horrible, but that's okay.
Like array input string.
Yes, so I can do input stream. Yes, that's what I meant. Yes. Now this is an input stream. When I call it, what do I expect to get?
Expect to get false.
Why false?
We put a space in front of yes.
But that's okay, it's gonna read it and then it's gonna read it again. Maybe. No, you're right. Should be false. I need slash n's, right? I do this.
Oh, yeah. I'm sorry, yeah, you wouldn't get
No.
false. You'd get
No, I would have gotten
You'd
false.
get like a recursion.
Yeah, I don't remember. Did we use next or next line? No, this just printed and ran.
It asks twice and returns true.
That gets nothing, then asks again.
Oh, there's two. Okay.
There's a slash n, and so that's an empty thing. What happens if I do this? It dies. Oh, so there is a
Asked
problem.
3 times.
Because I'm not checking whether there is a next line or not. Right? If I use next, this reads by word, I hope. So this would actually, right? This is not terribly important, right? You can go spend a week figuring out how input works when you need to. Normally you don't actually ever read from the keyboard. But here's the important thing. I can give you other stuff that's not the keyboard. I can, right, create test cases that use files. I can hook this up over the network with something. I could create a nice GUI program that hooks up the input to this thing, right? That's why I'm giving you an input stream and an output stream.
Okay, and that's more realistic because in the real world you're not going to be dealing with like keyboard inputs as much.
Potentially, right? It's just, right? It's in the real world you never do or seldom do these things, but it's more, right? That's why, in fact, I'm doing it to cheat because I need to test this thing, right? That's really why I'm doing it. But it makes it easy to test. It makes it easy. That's the kind of stuff that I do in my unit tests to verify that it worked. And so, but it is important because it can be changed, because it doesn't have to be system.in and system.out. Also, I like it because I'm a stickler for functions, and this makes it clear to me that you are gonna modify these guys. Whereas if not, right, to me it is horrifying when, and I tend to just bug you about it in code reviews or something like that, right? You write a function, you print stuff to the screen, right? You just destroyed whatever I was doing, right? I call the function to see if a number is even and you print stuff to the screen, right? You just destroyed whatever I was doing. I was trying to build this beautiful text-based game and you just destroyed it, right? Because you just wrote to the screen, right? It's like, I made beautiful N-cursive UI and you just destroyed it. Like that's your thing should not, you should never change global state without glaring claxons and lights telling you, right, stuff is gonna be changed. Because once you start changing global state, all heck breaks loose. So that's why I passed these things. Pure functions are a lot nicer than anything else, but if you cannot have pure functions, at least make the stuff that you're going to destroy obvious. On the other hand, for the purposes of this assignment, it's just to annoy you. Now, that's what it feels like because you don't see the complication, right? When you're doing it with bigger things, then it is important that nobody changes stuff without making it clear.
Wait, what's a pure function? Is that a void function?
A pure function is a function that has no side effects, that doesn't change anything outside other than I got inputs, I return outputs, I didn't change anything.
Right.
It's even, right? It's a pure function. You get a number, you get out a value, that's it, right? It's very close to the mathematical idea of a function, as opposed to this thing. It computed a value, but it also changed these two other guys, which is horrible, because now when you're calling these things, right, you need to start thinking about what the heck happened, right? And what if I do this? If I start to do this stuff, right, then it's like, oh wait, how many did this guy read? Do I still have enough? But right, your life just became so much more complicated. Because now you have to worry about sequencing, right? So this is horrible. It is much prettier if you have pure functions. You can't have pure functions and input-output, right? It is even worse if you're not passing those things and then just your code doesn't work and you don't know why. And that's because on the code that's 3 layers below that somebody wrote, they read manure from, right? So they write crap to the screen and now you just see all sorts of horrible stuff on your screen. So that is why, and to annoy you. That's an added bonus. Let's see, what other examples can we do? We did contains. Let's do the more complicated one. Int low, int high, int step. Hopefully that's not one of the assignments, but at some point in time my creativity dies. We're going to print from low to high by step.
I think it was one of the assignments.
Oh, then let's not do it.
We already did it, right?
Did we?
I don't know, I can't remember.
Yeah.
Just do whatever you, I'm talking, I'm being a loud mouth. You guys just.
Let's do something different. Let's do void print squares. This is almost the assignment. Int from int to. We're going to print the squares of the numbers from to 2. And I'm going to make them inclusive. Because why not? Make sense? Let me actually cheat and do int square just for fun. Int n. Returns the square of n. What do I return? So what do I do? I'm gonna go up from onto 2, right? Shall we call it from and to or just low and high or something like that? Low and high? So what do I do? Print out dot print ln, right? Square of who? And what else? Sorry?
No, you don't need, not you need it if they're,
I think you need to use
assuming
it.
it's already less than equal to, you don't need an if statement.
I'm only printing it once. I'm not printing all of them. How can I print all of them?
You call it again.
How?
Print squares, low, plus 1, high.
You need to check though if low is equal to high
Yeah.
right now.
One sec. Let's. So what you're saying is low plus 1, high, and out?
Yeah, okay. Assumes low less than equal to high started out messed me up, but yeah, you would have that.
Yeah. So I need some sort of checking, right?
Yes.
Which I could write it as, okay, if I'm done, then just return and get out of here, right? Or put my ifs inside or something like that. How do I know that I'm done?
I would,
Low is greater than
I would say,
high.
yeah, low less than
If low is greater than high, that's one way of writing it, right? Possibly. let's see.
So I would define if low less than equal to high.
Yeah,
then
what?
do your print
Yeah,
line, then your print squares.
let's call it from 5 to 10 system dot out. Uh-oh, what happened? Why are you running? Okay, okay, it is there, right? We could write it more like this: if low less than or equal to high, then do this. Now probably write it this way.
You have to. Oh. Oh, you don't have to say return anything because it's a full way. You just let.
Yeah, if you're void, once you reach the end of the function, that's it, you're done, right? And there is no, yes.
You don't need to put else statement.
You don't always need to put an else statement, no.
Okay, it can be finished with only it.
In this particular case, yes, right?
Because both the conditions.
What do you do if that's not true? What would your else statement have? What do you do if low is greater than high?
Yeah, then we will put high is greater than low. Else means.
Right? What you are saying is if low is less than or equal to high, print the square of low and call it again. If it's not, what do you do? If low is greater than high, what should you do? Should you print anything?
Yeah, out dot println square high.
Why? Now, right? Count from 5 to 6. Say 5, 6, right? Count from 5 to 3. That doesn't compute, right? I'm trying to go up and I stop, right? So you wouldn't print high or anything like that. You would just, right? You'd not do anything, right? So your else really would be do nothing, but there is no particular reason to write this thing. And again, what happens if this doesn't make sense? Go type it on your computer, right? Try it with different things. Go try it again. Write it the other way. Write it. How many ways can you write it? There's probably, right, many different ways that you can write this stuff. This is probably how I would write it, but what does this look like in the assignment? This is FizzBuzz, right? Or print FizzBuzz or whatever. Right, and so there is all sorts of ways that you can just count over all the numbers and do things with them. What other things would be cool to do? Did we do Fibonacci?
No.
No. Oh, let's do Fibonacci just for fun. We did factorial. Fibonacci is the standard bad example of recursion. It's actually a very entertaining thing. If your kids are geeks, teach them how to do that, because it allows them to stay entertained for hours without the teachers noticing that they're not paying attention, right? You start with the number 1. Depends on how you define it. I tend to think about it as you start with the number 0 and the number 1, and then you keep adding. 0 plus 1 is 1, and now, right, you add the last 2. So 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, then 8, 13, 21, 34, right? And you can keep entertained for at least 5 or 10 minutes while your professor drones about recursion and stuff. How can we implement this with recursion? Right? So it's gonna be Fibo, let me call it Fibo, right? And what we're implementing is, given the n, the number on the sequence, right? You would return me the corresponding Fibonacci number, right? How could we do it? If n equals 0, right? Or n equals 1, what do we return? Sorry, wait.
No,
If n is 0, I'm going to return, or yeah, I can return n. Yeah. If n, let me do it this way. If n equals to 0, return 0. Actually, just for paranoia, let me do this. It's not defined for negative numbers, so I'm defining it to return 0 rather than die. Else, if n equals 1, return 1, right? Else, what do I return?
Fibonacci n minus 1
And minus 2.
Is this cool? What is the problem with this function? It sort of kind of works, right?
It makes you think that recursion can do anything that easily.
It is. Recursion can do anything that easily. When you get to programming interviews and programming contests and things like that, a lot of those things are super easy if you understand recursion. They are just like tests for whether you know recursion.
There's a problem with it?
Yeah. System.out that print alone.
static.
There's 2 problems. Need to remember my magic and incantations. Fib of 5, it prints 5, right? Do fib of 10.
Oh.
55. Let me do this. Right? How long did it took to do fib of 10? 2 seconds, right? 3 seconds. Let me do 100. And then let me tell you about, oh, it's not that bad. It's, it's compilation. It's starting to run. So now let me tell you about the tale of Plagueis the Wise. Now, it's taking a little bit. That kind of sucks. Why?
Because it has to call it for every number down the sequence. You're calling it twice, and then it splits again, it splits again, it splits again.
Right? In order to get fib of 100, right? I call fib of 99 plus fib of 98. Then fib of 99 is gonna
98, 97.
do 98 and 97, right? So I'm doing a horrible number of things. I always say that it's exponential, but it may be quadratic.
I'm trying on everything on here says it's timed out.
Yes, it takes between 1 and 2 forever, right? Why? Right? I mean, that's why you don't do Fibonacci this way. Let me do something just for fun. Int.
So wait, so what's the duration of that?
It's still going.
Is that like 2 to the n or something?
Let me not lie to you.
You're the
Int
teacher.
num fibs equals 0. Let me do this.
Exam question.
You should never do this, but your function should never print stuff, right? Anyway, let me do, just so we can see it, if
Well, it's good for
num
like, debugging
fibs,
things.
yeah, %100 equals 0, print this thing, right? And then we'll do this, and then print num fibs. I'm going to do 10. Yeah, it's telling me that it took forever. So on 10, it took 177 total iterations, right? The 100, then the value is 55, then printed 177. Let me do 20. And I think that should be, oh no, it is exponential this way. It took 21,000 iterations. Oh, it is worse than exponential. With 30, it took an obscene number of iterations, right? 2 million, right? So this is horrible, right? Does that make sense? If they use this as the example in your intro to programming class in high school, that's why they don't do recursion, right? So what should we do to make it suck less, right? What we need to do is to pass the
This previous some Fibonacci number or something?
yes, right? Int prev1 int prev2,
Both of them, okay.
right? Actually, do this. So this is again passing state and things like that, right? So let's see. We'll keep this, right? So now if n is 0, I should be returning, let me confuse myself, prev2. Let's do this. N minus 1, previous 1 is going to be prev1 plus prev2. Previous 2 is prev1, right? This is the previous element, right? And this is one more.
Oh, okay. So prev2 just gets switched to prev1.
Prev1 becomes prev2. These are horrible names, but let's see if this actually works. And print fibo of 5. And then fibo of 5, comma 1, comma 0. Let's see if we get the same result. Should get 55. Oh, 5, sorry. That's good. 0, 1, 1, 2, 3, 5. Yes. Right? We started at 0. So if we do something like 7, we're getting the same results, right? Life is good. Now let's do 10, 10. Now, initialize nonfibs to 0, call this print nonfibs. we're calculating the same thing, right? But this one is going to be much less time. This one is linear, right? Because I only call it once as opposed to call it twice, right? So when I do, actually, let me do this even better. Int n equals 10. N. So we can change it. Let me eliminate this guy. So print less stuff. We did not. Where are you printing 100 thingy?
In the first one.
Sorry?
In the first function definition.
And that's the one that actually prints it. Thank you. So it prints 55 and it took me 177 steps. This one also prints 55, but it takes me only 10 steps. If I do 20, then one will do 20,000 and the other one will do 20. Does that make sense? So the first Fibonacci is horrible.
And I guess, okay, so that's why you coded it that way. That's why I was lost at first, because I thought you were saying, I thought you were going to make it too easy, but you could also do, like, instead of 0, 1, you could do 1, 1, right?
That's the other way of defining Fibonacci.
No,
Yeah.
no, I mean, even passing in your parameters, right? I mean, if you know, instead of starting at 0 and 1, you know that 1 and 1 is also a sequence.
But then,
2 is a sequence.
well,
Isn't that also,
I could, but then I cannot answer 0.
what do you mean?
0 has to be a special case. If you call Fibo of 0, you should return 0.
Okay.
If I start with 1, 1, then I cannot return 0. I need to do special cases.
Okay. You have to rewrite your method for it. Okay.
Yeah.
I get it.
Does this idea make sense? Did Fibonacci? We paid homage to the bad teaching practices of teaching Fibonacci. But it's actually important because of tail recursion and those kinds of things, right? What this does is this actually can be optimized heavily by the compiler, so they don't really need to do recursion. They could reuse the same stack frame.
And so, I guess to be completely complete, you write a wrapper around that? Or free
Yeah,
form
you would
is
normally
fine?
write a wrapper
Okay,
that only takes 1 and calls it with 0 and 1.
okay.
But I would need to call it, give it a different name. Does this idea make sense? If you're starting to like recursion, go read about Scheme, which is a different programming language. There is actually a couple of really good books. How to Design Programs is kind of a nice and gentle introduction, and this is an amazing book, all about recursion, but it will warp your brain. It may not be something that you go do today. If you're having problem understanding recursion, don't go do this, but just reserve them for at some other point in time. Yeah. Let me do this before I forget. Okay. Close this. Cool. Now I can leave. Any other questions about recursion? Shall we do? Yeah, we don't have. Next class we'll do a sample quiz, but let's do a couple more examples. We have about 15 minutes, right? Almost. So let's do more cool stuff. Fibonacci is mildly interesting, right? What can we do? We have done some input stuff. We have done a bunch of number stuff. Let's play with strings, right? Again, what can I do to a string? Can ask it for its length, right? And I can ask it for the character at a given point, right? And I can also concatenate strings, right? Okay, so how about, this is horrible, don't ever do it, but it'll work. How do you reverse string? This is a horrible implementation of reverse. You should not implement it this way, but.
You have to like turn it to an array first.
Last one, return a
Or you use a recursion thing.
Yes, let's use a recursive function, right? How do we get the first element? Car first. Well, actually, first of all, what's my base case? What's the simple case? What's the simplest string to reverse?
One string or one.
Empty string is even simpler than one, right? So what do I return? Empty string, right? Now the first character is what?
String dot.
That's the first character, right? Oh, I'm gonna do it the even uglier way. Let me show you one more thing just to make it the horriblest possible way. abc.car at 1 would give me what? B, right? Sub
You have to do a start and a finish.
has a different name.
I don't think that the sub, yeah, I think it's not capitalized.
No, it's cool. I'll remember that stuff. They put a poor high school intern to come up with these names. Actually, they have put different high school interns over different years, so there is zero consistency. I'm horrible at consistency, but this stuff needs a bunch of different
So
people.
there's a lot of different methods that some of them are capitalized and some of them aren't.
Yes, exactly. 2 lowercase is capitalized, but substring is not, right? And then it's even worse. We'll see later. There is stuff that has length and size. Arrays have a property called length. Other things have a function or a method called length, and other things have a function called size. And there is no rhyme or reason. You just have to remember which one has which. It's like, if I pass it substring of 1, this should tell me BC. Maybe, yeah. So if I do substring of 0, we'll return the same thing. Substring of 1 will take out the first character. Does that make sense?
So it just starts with like value given continues on.
Exactly. But those, of course, go by, well, I guess they go by 0, but they include the index that you pass, right? From where you're there till the end. Does that make sense? So what can I do here? I can do, or let's do first, and then let me
So what you should do is
string, just to make it clear, rest equals s dot substring 1.
Not do another base case if it's 1 and return 1? Or are you gonna?
I don't need to.
so you set substring now.
Okay.
And then right after that you say print.
Reverse of rest. And then what do I do with that other character? Where
and
do I
then you
put it?
say- Then you, is this to print it or?
I'm not printing, I'm returning.
You were, well.
You gotta add it on.
I gotta add it on
you
where?
have to concat-
The beginning or to the end? To the end.
Oh,
Does
okay.
this make sense?
I thought maybe you could like concatenate it after the, because you know how you're showing when you do recursion, if you like say you were just printing it, you could print and then do the recursive, or you could do the recursive then print,
Yeah.
and it would do it in.
That is
Flip
what we are
order.
doing, right? We are concatenating at the end instead of at the beginning,
Okay.
right? If we were to concatenate at the beginning, we actually just duplicate the string.
Oh, okay. Okay. Yeah. In a way, yeah. That is, you put it all in the return statement.
Yes. Let's see if this is true. Oh, that doesn't work. Maybe it would actually work. Yay! This is horribly inefficient. Don't ever do this. But in terms of teaching you recursion, it's probably useful. Hopefully. We have one more. Let's do how many times does a character occurs in a string? What's our easy base case?
Empty string.
Empty string, right? For when you're doing, right, kind of like, chances are that your base case for numbers is going to be 0, right? Your base case for strings is going to be the empty string. So if s equals the empty string, what do I return? How many times does a character occur in the empty string? 0 times, right? Now I need to check. Let me do the same thing, just to make it clear what we are doing, right? I need to check whether the first equals to the character C. If it is, then what do I return?
One plus the column of.
Oh, and I need to do rest. If it's not, then what do I return? C, comma, rest. I'm really returning 0 plus this, so I can just return this, right?
Do the call without the plus, yeah.
Does this make sense? May even work. Yay! No, never. I'll actually, if you don't see this posted by tomorrow, remind me, and I will put all these samples in a place where you can access them.
So we'll start from 0, give you 2. The first
It will, the string is A, B, C, D, A, E, F, right? It will check, is this string equals to this? No, right? Get the first, which is the letter A, the rest, which is B, C, D, A, E, F. Is the first equal to that? Yes, right? Then it's going to return 1 plus count occurrences of the same character, the letter A, but now on this piece. Right? So it's going to come and say,
Is that to the position of the?
we are really not iterating over positions. In some other examples, I iterate over positions. Here we are iterating over strings.
Okay.
We are creating smaller and smaller strings. Right? This is even less efficient than iterating over positions, but it's pretty.
And that's why each time the first changes.
Yes, the first changes and the rest, both of
Yeah.
them change, right?
It's kind of like the pointers going.
Yes. Cool. Then I will see you guys on Wednesday, probably. We will probably do a sample test and see, right? Because you all understand recursion, right? You didn't ask any questions.
So, when is the test that's coming up? Or the second?
Wednesday, the 25th, right? 20, yeah, whatever. Yes, 27. Monday, the 25th. Wednesday, the 27th. That's what we had agreed, right?
Just during regular class time?
Yes, yes.
And what are the topics we're going to cover after the midterm?
After the midterm,
Yeah.
all of this stuff.
Also, it's just gonna be on.
Okay.
This is up until recursion.
Oh, we got an assignment on loops due on Sunday, right?
Yeah.
Did
But
I,
it just won't be
do
on
I
the
suck?
exam, maybe.
Yeah.
Yeah, we got one too.
Actually, I'm gonna
Extend.
change it and make it due on October 1st. There is no reason to make it due, right? Yeah. Oh, yeah. Then, yeah. I'm gonna make it due on October 1st. Cool. Let me stop this stuff.